Welcome back. This video is going to talk about bivariate descriptive statistics. So how can I understand the relationship between two variables? In particular, how does one numerical variable depend on a categorical variable? Before I get into that though, I want to take care of one housekeeping thing, which is the notations that you're going to see. So up until now, my discussion of both measures of central tendency and of dispersion have assumed the population notation. Okay, so what do I mean by that? I've used big N as the number of elements in the population, mu as the population mean, and sigma as the population standard deviation. Now, when we are analyzing data from a sample, as opposed to having the whole population a census, we're going to change our notation just slightly. So the first thing we're going to do is we're going to use little n and reserve little n in this class to indicate the sample size, so the number of elements or units that we've sampled. X bar is going to be our sample mean. Turns out the sample mean that we'll use is computed exactly the way the population mean is computed. Just add up the values, divide by n. The sample variance is going to be s squared. The sample variance is computed almost the same as the population variance, except that we're going to divide by n minus 1 rather than n. The reason for that we'll discuss in a couple weeks when we get to our module on estimation. The short answer to why we divide by n minus 1 is it makes s squared an unbiased estimator of sigma squared. More details on that to come. All right, the sample standard deviation is going to be s instead of sigma. So the point I'm just trying to make with this is we're going to change our symbols if we have data from a sample versus data from a census. But the basic meaning is the same. So the sample mean tells us the middle in the same way the population mean tells us the middle. The sample variance is an indication of dispersion, just like the population variance is an indication of dispersion. All right, so how do we study dependence? So in particular, let's say I've got some dependent variable, some language that we'll be using, that we think depends on some independent variable. So as a very simple example of this, maybe I have an independent variable, which is whether you get a new drug or whether you get the placebo drug. So that would be an example of an independent variable, something that I can manipulate. Do you get the real drug or do you get a fake placebo drug? And then my dependent variable is maybe something like, do you get the disease? Yes or no? So that could be one example of a dependent variable, or maybe the time until you recover. So that could be a numerical dependent variable. And I want to understand, how does the time it takes for you to recover from this disease depend on whether you get the real drug, this new drug, or whether you get a placebo treatment? All right. The answer to this question is, in general, study the distribution of y for given values of x. Now, back in probability theory, you probably studied conditional distributions, and that's really what we're talking about here, is the distribution of y given x. Now, to start out with, we're going to do some very simple single number summaries to summarize the conditional distribution of y given x. And then we're going to look at more complete pictures of this conditional distribution with both box plots and multi-panel displays of, say, a histogram. All right, So the way we're going to summarize the distribution of y given x is just to compute single number summaries broken out by x. Okay, so what is the mean of y for different values of x? So as a simple example of this, let's go over to the employee data set. And so I can just go over here, and another nice command to know about is view. So view spelled with a big V. If we view employee, we can see what the data set actually looks like. And so what we have here is about 70 some employees at some company, and we know their salary, we know things like their gender, their training level, how many years of experience they have, and what is their age in years. All right, so we could ask a very simple question like, how does salary depend on training level? Or how does salary depend on your gender? So there are a couple ways of computing this. What is your average salary? What is your median salary, and all that sort of stuff. I think the most useful is a package called dplyr. So I strongly encourage you to learn dplyr. So dplyr it's like SQL. So I think all of you have had the relational database class before taking this class. You could do all this in SQL as well. dplyr is a little bit like SQL, but in some ways it's a little bit more flexible and easier to use. So I'll just go over to R, and we'll run this stuff live here. I got to go find the example here. Here it is. So what I'm going to do is take my employee data frame, and I'm going to send this into a series of dplyr commands. So this percent greater than percent sign is called a pipe. And so we're connecting this data frame. We're going to send this data into some other commands. Then I'm going to group by, so this is a lot like the group by command in SQL, some categorical variable usually. So in this case, let's group by female. And then after telling dplyr that I want to group by female, we're going to summarize the data by female, so by male, female values. And I can just list a bunch of variables that I want to compute with how I compute them. So for example, n is going to equal this n parenthesis function, which is just going to count cases. I'm going to define another variable called mean, which is a function mean evaluated on salary. Median, the min, the max, all that sort of stuff. So let's go run this. And so what you'll see is that now I have two values of female. In fact, I'm going to go put some levels on this. So I'm going to assign the values male and female. I did this in the course packet as well. And let's rerun this. And so what you're going to see now is we have 28 females, 43 males, and we can compare their salaries, their medians, the mins, the maxes, and you could add to this. We could do standard deviations, we could do whatever you want. All the single number summaries that we've covered can be computed here in dplyr. All right, I'll just mention another way of doing this, and it's with the psych library again. We're going to use the describe by function. So with describe by, I give the variable I'm interested in, my y, and then I give the x variable, in this case female. And so what you get are all the descriptive statistics that we usually care about, computed for both males and females. You get the same answer. I mention them both just because this is a bit easier, but less flexible dplyr command, we're going to use, be doing variations of this so many different variations that can't be done by describe by. So it's, I think, worth learning both. I threw in a slide showing you how to do this in SQL, if you like. So you install the SQL df package and then bring it in as a library, and then you can execute SQL commands within a quoted string. And so if you remember your SQL from the relational database class, you may prefer that. It looks very similar to the dplyr, and I'd encourage you to learn dplyr. I'll just mention one more thing. You could condition on more than one x variable. So this gets us to a multivariate analysis. So how does your training level depend on both your salary depend on both training level and gender? And so here I compute the mean salary, the min, the max, whatever you want, broken out by both training level and the female variable. And so I've done that just by listing both the variables in my group by command. All right, I encourage you to watch the box and whisker plot next.